Okay, first I have to admit that my meeting is being recorded. Okay, great. So thank you very much for inviting me to speak today. I will attempt to go quickly enough through my slides, of which there are too many. So I want to start off by giving you a little bit of an introduction to the OGC and COSI, which is the innovation program. It's familiar to several people in this room because you're involved in our initiatives, but just for anyone who doesn't know it very well, and then jump into talking about the Open Science Persistent Demonstrator, which is a initiative that I'm currently the project manager for, which really is a distributed platform for standards-based geospatial open science workflows. I don't know if that was the original conception when people started to come up with the idea for the OSPD, but that's what's happened. So that's always fun. So for anyone who doesn't know the OGC, we are a not-for-profit organization. We support the global geospatial community. We're probably best known for our work on all things standards. And we also spend a lot of time and effort supporting the location community to develop consensus standards-based solutions. Consensus standards meaning that people get together and have long arguments about what should be in the standards, hopefully come to a consensus, and that is where they come from. We're quite a big community. We have more than 550 members, more than 90 working groups, and we do a couple million every year in project funding, meaning that we give that funding out to organizations like yours to participate in our initiatives. So if you're interested in getting involved in OGC COSI initiatives, I'm a good person to talk to, and I will try to convince you to join us. So in summary, what do? We do innovation work. So we say, how can we help people to build systems that track the locations and trajectories of millions of autonomous vehicles? I didn't know this was going to be such a relevant example today. This came up in the NSDI workshop last week, where people were discussing the vision for the future US NSDI and what relevant use cases are. So we say, how do we help do that with standards? There are more than 1.7 million operational data sets that use OGC standards. So the standards we develop are actually in use. Everyone probably knows WMS, which made internet maps work back in the day. Now we use other things. And we're a very large and old nonprofit group with lots of geospatial technology experts. And our members like to get together on calls like the one I had to jump out on before, and also conferences like the member meeting last week. So what I'm going to talk to you about today is an initiative that is happening through our COSI program. This is our innovation program. So the way I like to explain it to people is that we have this whole process, right, where standards are being developed through debate and discussion amongst geospatial experts. We then come to some sort of consensus about that standard, and we then on the COSI side kind of say, okay, nice standard that you've got there, let's try and use it in the real world and apply it to something. And we then basically come up with use cases and requirements and do our very best to see what does and does not work in those standards. So we are the breaking the standards to make it better half of the organization. And we then feed back the results of that to the groups who are putting the standards together. So that's basically the process that the project I'm going to be talking to you about takes place within. So more to the point of what's going on at this meeting and in this context, the OGC community, and particularly the people involved in COSI initiatives, have a real challenge. Our members, because there are over 500 of them, produce thousands of applied research products. They produce code, they produce data, they produce live services, they host platforms, they write reports on all of this. And many of them value collaboration and coordination to advance solutions that leverage geospatial data and technologies. They wouldn't be involved in an organization that goes through this consensus-based standards process if they didn't value these things. And many of them also really want to use open science and FAIR principles to work together more effectively and have greater impact. And this isn't just our members from the pure research space in the sense of academic research. This is a set of operating principles and topics that are incredibly important if you work in any position of public trust or public authority. So if you work for a government and you're doing science, data, evidence-based decision-making, FAIR data and open science principles are key things. And so I really want to underscore that in the context of our project and where I think science and research practice is today. So the OGC community is really within this project, this Open Science Persistent Demonstrator, looking to serve organizations that want to follow these open science principles and also need to or want to conform to OGC or allied standards like ISO standards. Because they need to maintain fair data, they might have a public trust mandate that requires them to do this, or they might just think it's good practice for building trust in their products and services. They need to create portable, transparent, reusable services. Every time I talk to government agencies, I hear about zero trust and integrity, provenance, and trust. These are key topics, so people need to be able to do this. They need to be able to assure all of these things. So this is kind of the user requirement we're trying to address. So I've grayed out the first bit. Our users are incredibly demanding. They also want to be able to perform these complex multi-step workflows where they're leveraging data, analytical, and computational services that are hosted on multiple platforms and serve data out to other platforms. And now we're starting to move into this mental space of federated things, right? So if I want to use Landsat imagery that is hosted on NASA's server, and I want to run a large-scale analysis that runs well on HPC, and my HPC resources are out at the University of Indiana through the iGuide program, and I want then to visualize my output using NASA's VITA service and their platform, and I want someone else to also be able to ingest that via an API. I am working with components, workflows across at least 4 different platforms. Okay, this is how people actually, I think, want to be able to work. We're no longer in the model where everyone just pulls it onto their own computer and does it themselves. So we are out in the wild on the decentralized web. So we are looking to try to build a platform to meet these community needs. And this is really the heart of what's happening in the Open Science Persistent Demonstrator. Our work is being funded by NASA and the European Space Agency, who serve the science community. That is certainly a huge part of their user base, but they also serve a lot of government agencies. NASA and ESA data are used widely in public trust applications, and they also serve the business community. ESA and NASA are very invested in science being taken into industry. So they are behind all of these things. So when I think about who our users are for this system we're trying to develop, and how we can use these principles of open science and kind of federated distributed systems, there are 2 groups of users I always have in my head. On the one hand, we have kind of what I think of as the city planner, right? Who is doing research, doing analysis to inform decision-making in a position of public trust, who might be saying, what can my city do to adapt to climate change? So that's their end use problem. We also have, on the other hand, all of the people who are providing spatial data access, providing analysis, providing modeling, who have all of the data, have the processing power, have the services set up. And they are often struggling to connect. So we've got the user who needs, as I said before, to use data and services across multiple platforms in their workflows. They ideally do not want to be paying an arm and a leg for cloud computing. I think everyone has met this problem at some point. And they often don't have specialist technical or coding skills. Sometimes they do, but sometimes they don't. On the other hand, we have people who are providing data and services who want to bring users to their platforms and services, even when they can't provide an end-to-end service for a specific workflow. So you might be saying, we are specialized in providing analytical services, but data visualization is not our jam. We want you to get that somewhere else. So how do we allow people to specialize while meeting diverse needs? So apologies for small text on the slide. We want people to be able to build and run unified workflows across multiple geospatial platforms. They should be able to discover components from multiple places. They should be able to connect them together into a workflow. In our universe, preferably using standards conformant APIs to pass data between platforms and services. They should be able to execute workflows using components ideally on people's native platforms, meaning that we're not moving stupidly large geospatial data sets unnecessarily all over the internet, data at rest as much as possible. They need to be able to save and export the workflow so other people can reuse it and adapt it. So this is kind of an open science principle, right? Reuse, that far end of the FAIR spectrum. And we also want people to be able to document the workflow and its components as automatically as possible because humans do not enjoy filling out their metadata. I've yet to meet a human who really wants to spend all their time doing their metadata, but it is absolutely necessary if we're going to achieve integrity, provenance, and trust, right? If we don't document this stuff, we don't get to those aims, but we want to make it be less painful. So we're trying to assemble this kind of federated architecture to meet all of these needs. So we are at the beginning of the process, I should say. We are only a few months in. It's going to run over the next almost 3 years. So please bear with me if there is anything that is unresolved or anything that I come back and tell you is totally different a year from now, because we are probably going to change our minds. But I want to start at the beginning, which is why not just use an existing open research platform like a single one and move data and research code onto it? I've already alluded to this a little bit, but basically no one platform excels at all of these tasks. Open science in the universe of the modern web and thinking about the challenges we've been describing is really complex. So we want to be able to use multiple analytical services, multiple visualization services. Some platforms are very good at curation, enrichment, and archiving. Some are very good at workflow orchestration. Some are very good at validating standards conformance, right? So we need different things, and we want not to centralize, but to assemble. We also have a very different, very human challenge, I want to say, which is that the communities we're trying to serve hang out in different virtual places, right? So different platform ecosystems. So the people who are the librarians hang out in different places than the algal bloom scientists hang out in different places than the geospatial people. In my experience, it is much easier to solve the technical problems, so to build new technologies, than it is to build new communities. So I think we have to recognize that these communities have different backgrounds, different tool sets. They're just, in their different virtual places. So how do we kind of work around that? So in trying to bring together our user communities, our geospatial service and platform providers, and our science community and the OGC community, we have come up with a distributed infrastructure. And what we are basically doing is building around 4 key elements. We are using the OSFIO platform, and we're going to be hearing from the Center for Open Science team later in this meeting, really for metadata enrichment, archiving, and discovery. That is what that platform is very good at. That is where a lot of the research community sits. So we said, okay, we're going to use that. We are using something called the Galaxy project, which is essentially a workflow orchestrator. It originally came out of, I think, genomics is where that really came from. If you look at their core user base for workflow prototyping, composition, and orchestration. So we're using it for that. It's very, very good at letting you build code-based tools. You've got a bit of a GUI if you don't really love coding, so you can kind of have a low-code environment. You can build your workflows. We then also have lots of different data and services. So this is all of the icons down here who can essentially plug into both the OSF and Galaxy to build their workflows, document them, enrich them with metadata, make them be hopefully more discoverable. And the OGC is sitting up here really providing the standards conformance and ongoing standards updates that from a technical point of view will allow these different kind of workflow elements to plug together into larger, more complex workflows. So this is our pretty distributed infrastructure. So we've got our community of potentially interoperable platforms that provide data and services of the geospatial variety. And we should say these are the groups that we're working with now, but the idea is that this architecture will be open and usable for anyone who is willing to adopt and implement the standards to be able to fit in. They provide data exploration, they provide analysis, they provide visualization. And just in brief, basically, they all implement one or more, generally more, OGC standards and OGC APIs, which are providing the foundation for interoperability. At the moment, in the OSPD, we're focusing on OGC API processes and OGC API features. But again, this is kind of the beginning of a long process, and also Stack and Stack API. So I'm not going to go into the detail on that for reasons of time, but happy to chat about it later. So basically, each of our platforms within the community are implementing either OGC API features or processes to provide interoperability or Stack for search and discovery. So we are then working with the OSF, as I said, as a discovery, archiving, and metadata enrichment hub. So what we're doing there basically is using it to integrate with people's GitLabs so that we can connect to where code is being developed and maintained. We're using it to issue permanent IDs for lots of different entities. My call this morning was arguing about which entities should and should not get permanent IDs and whether or not platforms should get permanent IDs, depending on how they manage their versioning. You all can get involved in that argument at some point over coffee. And they are providing for us a research hub to register and find geospatial platforms and services. So that's where we see them fitting into the architecture. So Galaxy, for anyone not familiar, is, as I said, our place where we are implementing our workflows. So again, I encourage you to go out and have a look, but they basically have over 5,000 tools registered in what they call their tool shed. They provide kind of a plug and play compute infrastructure. They are funded by the NSF and the NIH here in the US, and they're part of the European Open Science Cloud. Lots of training resources, so a really good place to do that. And we're using them as our workflow environment. Low-code GUI, they provide peer review of tools, community support for training, and importantly for us, connecting through to OGC API processes. They enable and facilitate export of workflows to CWL, so Common Workflow Language, which again provides us kind of a standard-based way to document these consistently. So we are using Galaxy for our workflow orchestration, where basically you are providing an API process. You can send it and get it wrapped using our Galaxy Wrapper Builder that we are currently developing, and then contribute that tool via the peer review process to the Galaxy ecosystem to make it available for other people to pick up your tool, adopt it, make it part of your larger workflow, and then capture that tool and the larger workflow and register those on OSF. So that is a very fast version of what we are trying to do there, creating those registration templates on the OSF. I'm going to skip forward a little bit. So the idea basically is that you are a research scientist, you want to develop an open workflow, you go, you find tools you're interested in code, you create your repo on GitHub, you are accounting for your licenses, you create an analysis using your open standards and maybe an open source toolkit. You collect your key metadata so that it gets passed on to other steps in the workflow. You are modularizing or containerizing your workflow, you're implementing APIs, you're following best practices, you get all of this set up, and you're then registering your workflow on OSF as a project. You are including information on algorithms, paper, and code used. You get a DOI, you add relevant metadata, you implement your wrapper, you commit it as a tool on Galaxy, you get everything passed on, you publish your workflow on OSF and elsewhere, and you make sure that everyone has been acknowledged. That sounds like a lot of work, and I went through that very quickly. So now coming to our current challenges to wrap up. People do things in different ways, right? So a lot of text on this slide. Basically, we have processes, descriptions, we have implementations of metadata, we have all of these standards. Do not get me started on the argument about authentication methods. So, there are a lot of practical challenges in how to do this. People are laughing like we are going to argue about authentication. So we've got lots of technical challenges to solve, but what I think one of the biggest challenges is what I think of as return on investment here. So what I've just described, what we're trying to build, what we're asking people to do is a lot of, even with automation, human labor, right? So many of our platform and service providers are saying, we don't see strong ROI in providing all of this detailed documentation on our services and on our platforms in the way that we are asking you to do it. So I think this is something that is an ongoing debate in the open science community, who have been advocating for years for people to put in this effort and making that ROI case. But I would say that we are still having to make that case, certainly within the geospatial community. And if we think about public-private partnerships, this is going to remain a bit of a pain point. So I'm very interested to hear views from some people in this room from an industry perspective on this. And maintaining coherence with a large community is challenging. So just tagging out to answer some of Taylor's questions, things that are special for geospatial community-based challenges. Our data updates all the time. It's very large. Workflows often do go across multiple services and platforms. We have lots of application domains, making it hard to specify. And seemingly unconnected data and services are linked by location, and these links create real-world impacts. So geospatial does actually have some pretty unique problems to solve. So we are going to take all of these challenges and convert them to design principles. So if we've got lots of diverse data, we do data by reference. We have lots of applications. We talk about intended scope of application. We are going to try to minimize the effort required for things like getting into Galaxy, but we recognize that it is an ongoing challenge. We recognize the challenges of limited, say, geospatial community presence somewhere like Galaxy. How do we bring these communities together? I think that is a core challenge for us, how we get our end users and our geospatial platform and data and service providers to see the value in being in one another's ecosystems, and how we make this kind of ROI case. What is the value for platforms who specialize in providing geospatial data services and connecting to interdisciplinary platforms? I think this is underproven at this point, in spite of the strong efforts of the open science community. So why contribute? We can tell people that it's going to make them more visible. We can tell them that things are going to be easier to understand. We can tell them they're going to grow their user community. We can tell public trust research users it's going to be easier to prototype and build, and that there are going to be built-in features for traceability, integrity, and provenance. There are lots of reasons to get involved. There are lots of challenges. Please join us to learn more at future workshops. I'm going to stop there because I think it's time for other people.
Thank you so much. Time for questions.
Yep. Back.
I think one of the things that was part of that people talk about is kind of curious on how you guys go about just working within these systems that have like very tight restrictions that may actually, you know, making the calls. When I say making calls, I mean like not being too rigid or not being flexible. Like I know there's a lot of so yeah.
So if I understand correctly, it's a question of how within an open science workflow, we might say integrate with, not to pick on them, but DLR, who are one of our German Research Institute partners who have a lot of restrictions on accessing their data and services. Is that kind of where you're going with this?
Yeah, I think that's a good starting.
So I would say this is not a problem we have solved, hence I'm tapping out to being early in the process. I think part of it is recognizing that you can document the presence of an element in a workflow. So in a workflow description, so say in CWL, even if that means that someone who doesn't have the right permissions can't rerun that, right? So if we think about levels, I would say it's a compromise. Ideally, well, okay, we can talk about whether or not ideally everything being open and accessible is where we're going. But I think I can say DLR provided component 2 in my 6-component workflow. Sadly, you can't access component number 2, but at least you know enough via the metadata about what was there. That you can understand something about what was done. So for me, it's leaning on the metadata to help to describe something that might not be fully open and accessible to everyone.
Okay, yeah, that kind of gets to the point of like being able to reconstruct data so you have that.
Yeah. Now, if there are organizations who aren't comfortable sharing at the level of not wanting to provide enough metadata to enable that reconstruction, I think I would be more hesitant to use them in these workflows. But I think this is the discussion point, is how much we can do in terms of reconstruction via metadata, even without giving kind of permission to access the service itself. You had a question as well? Yeah.
I have two. I mean, just to tack onto that, I mean, that's where some of the beauty of like the content addressing comes in really nicely, because you can have a content address, but not provide access to the content. And you have this sort of like verifiability